Great. Well, hello, everyone. Thank you for joining us today at today's AVA session. I'm Christina. I will be helping out facilitating Q&As with Bill today. Today, we're going to be talking about Inventor API. So we're really excited, and thank you so much for taking over today's session, Bill.
Thanks, Christina.
Hand it on over to you.
Okay, so welcome everyone again. We're gonna keep going on this kind of Inventor API getting started series. Today we're going to be talking about attributes. If you haven't been on a session with me, I'll go ahead and give you kind of a little intro. I'm Philip Cox. I'm an application engineer at KETIV, and I develop software solutions for our clients, which is really fun because I get to touch a lot of different kind of problems and different types of manufacturing. It's a blast. So I graduated from mechanical engineering, BYU. I've worked for several different knowledge-based engineering groups, Spirit Aerosystems, General Motors, working on automating process engineering and design processes. And I also worked on an education field team, teaching Fusion to professors and students. So if you haven't seen our series that we're doing, any of the previous things, I'd encourage you to go back to kind of the start and look into those. Don't leave us right now to go do that, but it'll get you started at even just connecting in Visual Studio up with Inventor to get an add-in going, and walk you through several basic things that you can then apply to your work to solve problems. So there you can see kind of the three first ones. So what are we going to do today? Our agenda for the day is we're going to talk about attributes, their manual use, kind of like how to add in attributes just by clicking things in Inventor. But then we're going to also go look at how to write them programmatically and how to read them programmatically, and also why you'd want to do those things, some of the uses. Next, we're going to kind of jump into a computer fan case study. So if you were with us on my last AVA a couple weeks ago, we looked into object-oriented programming, and we used the computer fan as a case study to explore making classes that define kind of a fan, a grate, and a base for the fan. So we've kind of expanded that little part of the application, and we'll look into kind of how and why, and then how that applies to attributes. Is we're actually going to look at preserving that data. So if the user inputs data through a form, and you get data into your data structure, then when you close down Inventor, you're going to lose all of that. So when you reopen Inventor, in order to get that back, you need to have some way of reading in that information. One of the ways is through attributes. And so we're going to see that applied in the computer fan case study. So without further ado, I will turn off my video so you can focus on kind of the screen, and we'll jump in. Okay. Let's see, there we go. Okay, so first thing we're going to talk about attributing. In this case, I'll show a face, but really attributing anything manually. Now, there's two ways of doing it now that I use. One is in about, I think it's Inventor 2021. It might have been 2020, but they introduced a new feature where you can assign a name to a face. And this makes attributing a whole lot easier. And we used this previously in an AVA where we talked about drawings, automating drawings. And so really you just right click, you assign the name, and then you can actually pick the name, and you'll see in your geometry under your iLogic kind of folder there the different names. So we'll go and look at this This is not what we're going to be using today for a specific reason of it allows you to do the name, but that name is a value in the attribute. It's not actually the attribute name. So it picks its own name. So what we're going to be using is actually a tool that's provided by Brian Eakins. So if you want to go grab it, if you don't already have it, there's the URL, which will, here, actually, let me pull up the page that it will bring you to. So this is what it'll look like. And you can go ahead and download this nice little add-in here. But it allows you to view and edit or add attributes. So why don't we jump into Inventor? So let's click here and pull up Inventor. I'll kind of show you how that works. So we're in the computer box part here. I'm going to just, you'll notice that here in Tools, I have that attribute helper. But first, let's show you the assigning a name. So if I right click on this face, I can come down here and assign name. I can, name it front face, hit OK, and that will put it down here. You'll also get this nice thing there. Now, if we jump into the attribute helper, you'll notice we now have an attribute on the face. The attribute set is named thusly, iLogic entity name set, and the name is iLogic entity name, which is really not useful so much, but it does give us the ability to very easily put that front face value in there so that we can look for that. However, today we need to put something else in that value. So we need the front face to be the name here. So how we do that is inside, when we have this attribute helper open, we can actually click, and you'll notice there, add attribute set. And then it's going to ask for a set. Since we're doing AVA today, we'll go ahead and name the set AVA. And there it pops up on the face. And then we'll add an attribute there. And we can name this one front face. And then let's say we had a value that we needed to record here. I'll just put the number in there. And there you can see. So this can work if, for example, in our drawing AVA, we were just wanting to grab a face, and that was kind of static for each part as it dropped in, and we just needed it later on. However, if we are wanting to write to this programmatically, because it's going to change this value that we're dropping in, then we need to do that through the code. So now with all of this in here, I'm actually going to go through and delete what we just did. Pull this back up, say delete, and we'll jump back to the PowerPoint and talk about next steps. Why don't we pause for a second? Christina, do we have any questions up to this point?
Yes, we do. So Claudia would like to know, does the front face value have to be a number? Can it be a text string?
That is a good question, and the answer is yes, it can be a text string. In fact, I think it defaults to text, even if you put a number in. So you'll see that what we write to it programmatically will be a string. So good question. Any other questions, Christina?
No, not that I can see.
Okay, awesome. So I'll go ahead and go to the next slide. So how do we create an attribute programmatically? So we're going to look at the code kind of in a little bit of a abstract way first, and then we'll dive into the example. So first off, I saw a question pop up from Eric. It says, can this be applied to sheet metal components? I believe so, Eric. I haven't done it personally, but putting attributes on things, I'm pretty sure works with sheet metal as well. So, oh, we got a lot of good questions here.
Yeah.
Can you use Claudio asks, can you use attributes to identify painted faces for a model to then quickly change all painted faces from one color to another? So yes, because you're going to be grabbing the face, and then programmatically you can change that face to whatever color. In fact, you could change it to, you know, rainbow colors on different faces if you wanted to. So, I mean, as far as I'm aware, programmatically changing a face's color, you just need access to that face. So, you know, attributing it would be one way to easily find that. There are other ways you can grab a face, but attributing might be an easy way. And you could probably do that using the manual way that we showed first, where you're just, you know, attributing the face first, and then programmatically you go grab it when you need it. However, you know, maybe based on the user inputs that the user, you know, selects, different faces are going to need different attributes to then grab later. And that's another way you could do it. Cool. Good questions, everyone. Okay. So when we create the attribute, we're going to need to do three things. First, we're going to have to grab the attribute sets from an object. So we got to pick the object. Picking the object is actually just as important as what you put on that object. In this case, we're going to do a component occurrence because we want to be able to tell the different location that each occurrence is going in, and we're going to attribute it as such. Putting it on the part definition might be a good place if you wanted kind of to grab all of the occurrences, you know, and the definition. You could put it on faces like we've talked about. So after we grab the attribute sets from that object, we'll add a new attribute set. And then we'll add a new attribute to that new attribute set. So you can see the lines of code here. I have it in just a method that I can call. So I'm just passing in, you know, a name and a value and the object that I want to attribute, in this case, an occurrence. And there we just grab the attribute sets off the occurrence, set up a variable, and then I make an attribute set and name it AVA, just like we did manually. And then we're going to add an actual attribute here. And so we give it a name that we passed in. You'll see that we're doing a string type here, and then an attribute value. So whatever value we're passing into this function. And you'll see that kind of in action as we go along. Looks like we have another question from Eric. He says, can you use attributes in iLogic in an iPart or iAssembly? And how can you push them to the members? So yes, you can use them in iLogic as far as I'm aware. I haven't used a whole lot of iParts and iAssemblies with attributes. So just off the top of my head, I'm not sure how you push them to the different members, but I'll have to look into that and see if I can get that answer to you guys. So good question, Eric. Okay, let's go to, so we talked about creating an attribute. Next, we're going to read that attribute. So once we, you know, write it onto the part, we close Inventor, open back up Inventor, you know, we don't have the data we need. Or in the example, I think Claudio gave that where you're trying to paint faces, maybe you're trying to find which face you want to paint red. We need to read an attribute. So here, once again, I dropped this into a function, but first we need to get the object with the attributes, and then we need to find the set by the name that we're looking for, and then find the attribute by its name. So this I've built into kind of a function that can go through all the different attribute sets in an occurrence and grab one that matches the set name and attribute name. So you'll notice We pass in an occurrence, the thing we want to grab the attribute off of, and we're going to for loop through each of the attribute sets on that occurrence. Now, be careful of the Inventor likes to start at 1, not 0. It caught me when I was doing this. So keep that in mind. So we're going to for loop through each of these attribute sets. And we're going to check, hey, do you match the attribute name or set name that we're looking for? And if it does, then we'll for loop through each of the attribute names inside that set and check if it matches the name we're looking for. And once it does, we'll return that attribute. If we don't find anything, we'll return nothing. So that kind of gives you one example of being able to read through all of the attributes on a occurrence and pull one that matches a set name and a name. Okay, let's go ahead and jump on into the case study. So if you were with us last week when we went over the computer fan, we had a very basic kind of bunch of parts, 3 parts that had parameters on them that we turned into 3 different classes that represent class objects that represented those parts, and then a computer fan class object that represented the assembly. And we put functions in and kind of made it work in an object-oriented kind of basic way. I've gone ahead and expanded a little bit on that application part of our demo application through these AVA series, and made it so that once again we take input to a form, but we're going to define 3 computer fans instead of 1, and then we're going to place several of these versions into a computer box. It's a really realistic computer box. It, took me hours to make it. Took me about 10 minutes to make that thing, but it gives us kind of some reference. Then we're going to close down Inventor, lose all of that data that we had in our form, in our data structure, and then we'll restart Inventor and pull all that information back from the attributes that we wrote to those parts. And it will just populate the form. Now, we're not going to actually do anything with that information we would populate, but you can imagine the possibilities of, doing some edits and getting different information from it. So that's kind of what we're looking at. So why don't, before we jump in and talk about the code, because we've been talking about code a bit here, let's pop up Inventor and show you kind of the application, how it's working. So we have our this is actually the part. Let's close this out. No, we don't want to save it. Oh, still has that front face thing. Oh well. So here we're going to go ahead and open up our tools, grab our new computer fan form, and here you can see we have the 3 locations that we're going to place here. Now, if I wanted to be really robust, it'd be kind of cool to have a point selection, and you could put, the fan in different locations, and it would do a cutout of that location, which is totally possible. Just probably not under the scope of preparing for an AVA. So let's go ahead and turn on these locations. The first one we'll leave as is. We'll give it, we'll just kind of, give it 5 fan blades. How about that? Second one, we'll up the size here a little bit, maybe do it like that. We'll make a square grate, which when you see it doesn't really protect your fingers from the fan. And then we'll bump it up to, well, let's actually keep this as curved. We'll put a 6. And the last one, we'll keep that as is, and we'll go straight and go crazy with 8 blades. Then as we hit create, we'll see what happens. And they go ahead and drop into the assembly, populating as we have them. Okay, so that's fine and dandy. It doesn't have anything to do with attributes, except that now if we come in here, you'll notice that we have written to each of these fans. We call out what type of component occurrence. Once again, I'm just dropping in the individual part occurrences into this overall assembly. Probably not very realistic. You'd put it into a subassembly of the computer fan, but for time issues, decided to go that way. But we have the name of the part, the location that it's at, and the first kind of position in the value string here. We chose commas to be our delimiter. So there's the I believe that's the base width and then the base depth of the fan base. And let's see if we can find that's the grate. We'll look at, there's a fan. So fan, you can see also location 1. Curved is, the type of fan blade, and then how many fan blades there are there. We'll get another example here. You can see the difference. So we're just basically recording the information we will need to rebuild these in a string. Okay. I think I saw something in the chat. Huh. Yeah, Claudia. Case study, and it's a PC case. Didn't even think about that. Okay, so now let's go ahead and close out Inventor. So I'll go ahead and nuke that. Oh, I should have saved that. I guess we'll do it. We'll have to do it again. And I'll show you opening it up. Okay, so let's jump into the code here. So we're going to once again focus on reading and writing. We'll start out with writing because that kind of happens first. Oh, looks like we have a question from Cade. He says, can you have attribute sets inside of attribute sets for more organization? That's a good question. I do not believe so. I'd have to play around with that. Maybe if we have time at the end, we'll go try to do that, but I do not believe so. That'd be an interesting thing to look into. Thanks for the question, Cade. So with writing, so where we put the write function, we kind of looked at that write function abstractly, but where does it land? So I chose to put it in each of our different object classes. So a fan has a attribute method, a fan based does as well, and the grate does as well. Kind of following those object oriented programming principles of encapsulation, putting things where you can just call fan dot attribute and pass in what it needs. Each of those attribute methods are actually called from the place method of each. When we call fan dot place, it calls that attribute. So let's go ahead and look at that in the code. Pop up the code. While we're waiting, or while we're looking at the code, I'll actually start up Inventor so we don't have to wait too long. And let's look at, we talked about fans, let's look at the fan. So if you remember from last time, if you were with us, we have our fan class, we have all kind of the information we need. It also, oh, hello, Inventor, it has our place function. Now the place function is called from, now let me go to it. There we go. A place function on our computer fan class. So in here, we do all the things that we need to place our computer fan part, but we have a new line right here that just calls a new method we have that you saw before. And we pass in the name of the attribute and its its value. So in this value, the file name has the location at the beginning. So I just called a split function on the underscore and grabbed the LOC1 for location 1, or we delimit it with a comma and put in the fan blade type, delimit it with a comma, and then the number. And then that goes into the function, and it goes ahead and puts that attribute there. And so you'll see something similar on the fan base, where we pass in the box width and box depth, and also the grate, where we're also passing in the grate type. So pretty simple on writing, okay? Because it's just attached to that class, we can build it kind of generically, and every time it's placed, we just pass those values in. So we can call dot place, on a grate anywhere, and it's going to get attributed. Okay, let's look at writing, or sorry, that was writing, at reading. So reading's a little more complex in some ways. I probably could have incorporated more in the class objects. So, we followed kind of those object-oriented principles. For the sake of time, it kind of got just put into a method, and we'll look at that. So first, what we're going to do is we're going to fire we're going to handle a button click when the user clicks the reload button, and we're going to loop through all of the occurrences in the assembly. And once we grab an occurrence, we're going to read the attributes off that occurrence, get all the information that we need. We're actually going to make each of the parts, the different parts of fan base, and the grate. And then we're going to pass that into a new class constructor. So this is one thing we didn't really show on our last kind of object-oriented programming session, of building multiple constructors for different ways that you come about making a class. So let's go and look at it. Okay, so here, we'll start out by just showing we're on the button click here, handling that click. First off, we're just grabbing all the different locations. Now, this would not make sense if we were dealing with more than 3 locations here. So let's say you had a list box and you had like infinite locations that you could create. You'd want to, make a list and make this a little more flexible in that way. But for right now, we just have, those 3 locations. So we're going to loop through all of the leaf occurrences in this case, grab all of these occurrences, and we're going to pass it into the find attribute. So this is, if you remember this function, we showed it earlier, loops through and finds that attribute and passes it back out. Now, if it doesn't find it on that occurrence, this is going to be nothing. So we have to remember that. We check if it's not nothing, and if it is something, then we're going to go in and reload the fan base. So in this one, we'll look at the fan base example here. We pass in the attribute value. We split it based on our delimiter, and we know that the first one is going to be the location. So we grab that and do a select case on that location. And then the second one is going to be the width, and the third one is going to be the depth. And here is a great example of why you should comment and use better variable names, so that somebody else looking at this goes, what in the world is vals 1? But that's what it is. It's the width and the depth. So, and we just throw that into a new constructor, and it makes us a new fan base. And we'll go ahead and use the name already existing name property to store the location, because we'll use that right after. Speaking of which, once we make that new temporary fan base based on that location on the name, we'll go ahead and plug it into the appropriate variable here. And we'll do that for each of the different, so we did fan base, fan, grate. And once we get all of these filled up, down here, we'll check, hey, if location 1 has a fan base, fan, and a grate, we'll go ahead and make a new computer fan with our new constructor and plug it into that location. Let's look at that new constructor. So here, our computer fan constructor, before we took in kind of all the raw data, and then we went ahead and put that in the properties and called the different methods that would create fan base, grate, and fan. Now we did it kind of backwards, and we have a fan base, we have a fan, and we have a grate, and we just pass those in, put them in the appropriate properties that hold them, and then also pull off the data from those so that our computer fan class also has the box width, the box depth, and all the information it needs. And once we have that, we can go ahead and assign it to this specific location that's on our form. And we already have the methods built into our form so that when we click on a location button, it will load up the applicable computer fan information there. So all we have to do is just call a perform click on one of the buttons, and that will repopulate the form with the with the location 1 here. So why don't we go ahead and look at that? It looks like we have something in the chat. Eric asks, or is there a handout with the code he's talking about that we could print out before follow along to read? It's a little hard to read. Yeah, I agree. I'm going a little fast. I'll see if I can get you out just a text version afterwards to kind of go through. This will be on YouTube as well, so you can pause and kind of follow along that way. Yeah, it's a good idea to maybe think about getting it out early to you guys so that you could take notes on it. Thanks, Eric. Is there any other questions? Nope. Okay, so let's go ahead and run this, and this time I will save it so we don't have to do this again. So we'll open up our little example here. This is just a assembly with a part in it. Doesn't have anything else in it. So we'll open up our computer fan. Go ahead and I don't know. Let's leave this at 4 this time. Let's leave it basic. Put this at 6. And we'll, I don't know, let's make it skinny. Switch this. Put 7. Leave that as it. Well, we'll make this one bigger. And boom. Let's go. Now, any professional computer box maker will look at this and be like, it's floating in midair. But there's our 3 fans. They have the attributes on them. I mean, I guess I can click this and show you attributes on them. So now we're going to actually remember to save as. And I've gone ahead and we'll see how many different times I've run this in testing. Go ahead into our latest project, save this so we can go find it and crash it. Well, I guess not crash it, close it. And let's go find that file, pull this over here, projects. And here's our computer example. Load that back up. Always enjoy waiting while streaming on an application to load. Here we go. And there's our assembly. Now, when we go to our tool and open up our computer fan, you'll notice we've got no information, right? But if we hit our reload button, notice there it's gone and saved all of our information. It's pulled it back out. So that's the demo and kind of the explanation. I guess now would be a good time to pause to see if anyone has questions. Christina, are there any questions? I'm not seeing any through Zoom.
Yeah, I don't see any on here or from YouTube, or not yet anyway.
Okay, maybe we'll give it a little bit. And we can kind of talk on maybe one thing you guys can jump in on chat is kind of applications for this. This is, I mean, it's really useful to, if, for example, you wanted to edit any of these, you know, you wanted to change one of the fans, being able to pull up what things are in there so you can go ahead and replace one of the parts, delete. There's also, if you want to run a report, you had a report button on, this that would get a whole bunch of information from the assembly and feed out a report or an Excel spreadsheet that you used in other functions. It'd be useful to be able to do it after you first created the assembly. So if there aren't any other questions, kind of takes us to the end of what we're going to talk about, and we'll just kind of wrap up. So once again, I mean, if you've been on these series, you're familiar with this slide. Our team, this is what we do day in and day out. We automate for our clients and their customers. So if you're interested in learning more, maybe doing more specific training, or if you have a project that's kind of too big for your team, or you just want some consulting on it, let us know. That's what we do. It looks like we got a question. It says, not being a programmer, what would be the way to get to this level of code writing and understanding? Great question, Eric. So I would suggest beginning coding. There's a lot of tutorials out there kind of on YouTube to just get your boots wet, kind of moving forward on learning basic things. I would say play around a little bit in iLogic, doing select cases and things like that. Once you feel a little comfortable with like if statements, for loops, this series starts with how to connect Visual Studio with Inventor. So if I come up here, you just look up getting started with Visual Studio and the Inventor API, and this will walk you through step by step of how to connect those two up. And then we jump into really basic, no real methods. We just handle a click and make some basic geometry working with the Inventor API. And then each video we go a little more. So that's one thing that I would suggest. Once you kind of get a feel for your basic coding tools of if statements, select cases, for loops, and you want to start working with Inventor, then jump over to this series. Hopefully that's helpful. Let's spin back here. Unless there's any other questions, doesn't look like it. So also we're always interested in your cool ideas of what can be automated. And so as you jump on these future AVAs that we have, we're always excited to hear kind of your ideas and what you're working on. So next steps, if you want kind of to connect with us, there's my email, philip.cox@ketiv.com. I'm happy to have a 30-minute conversation with you about kind of what you're working on, where you want to go, or whatever questions you have. So feel free to reach out. Our team, we do mentoring, we do automation projects, as I talked about before, And if you're interested in learning more, there's our consulting services website. And keep an eye out for future AVAs. Who knows when I'll be back on here doing another Inventor API training. So if there's no further questions, thanks everyone.
Great. Thank you, Philip, for leading us today.